If you've ever seen synchronous technology in action, you've probably been very impressed with the fact that the user can put very little input into making a change to the part, but Solid Edge and the synchronous technology tools will actually enable you to make multiple changes simultaneously. If we take a look at this fixture guide block, you'll notice several different features. We have some angled cutouts here on the front end of the block. They appear to be coplanar with each other. We also have some alignment holes. They appear to be aligned along the same axis. We have two holes here on either end which appear to be concentric with the outside rounds of the part. If we flip the part over to the back side, we'll also notice some cutouts here on the back. They appear also to be centered on the part and also equal in length. And just by looking at the part, we can gauge some of the design intent just by seeing where different features are located. Let's take a quick look at an example of making a modification to a part utilizing synchronous technology. What you'll notice is I can select a single face on my part, and utilizing the synchronous steering wheel, I can make very quick changes to the part. Notice as I select the one face, it automatically finds the tangent faces, which is going to drive the overall width of the part. It's finding symmetry in my part model, and it's basically updating many things inside of the part with just my minimal input of selecting that one single face. In a similar fashion, if I were to select, for example, this hole here in the middle, if I drag it to a new location, notice how Solid Edge is picking up the other holes inside of the part. It's also, again, changing the overall length of the part as I adjust the hole there in the middle. How does it do that? Well, as I select any area of the part, you'll notice at the bottom of the screen we have what we call live rules. What live rules does is it's going to look at the geometry of my part and automatically detect things within the part. So if it finds symmetry in the part, it knows if I make a change on one side of the part to make that corresponding change on the other side of the part. If it finds things that are aligned, either in plane or along an axis, such as these holes, it knows if I move one or change one, you probably want to change the other one, and it'll do that automatically for us. So again, the live rules is a very powerful tool found inside of synchronous technology, which saves the user valuable time and valuable effort. What I want to do is I want to go through this demonstration, and I want to introduce synchronous technology. I want to introduce live rules and the steering wheel tool, which are two of the main components which make synchronous technology so powerful. But I want to introduce it in what we call bite-sized chunks. As opposed to just picking a face and pulling it or dragging it or putting a dimension on this model and watching so many different things update, I want to give the new Solid Edge user, or maybe the experienced Solid Edge user who's new to synchronous technology, more of a comfort level in how these tools work. So what we're going to do to start this off is we're going to actually turn live rules off and just show you different ways you can still work on the part, make changes to it per your input, and then hopefully give you this better feel for how the technology is utilized. So in a traditional modeling system, if we're going to make the comparison, what you're doing today, if you are utilizing traditional methods, is you're creating sketch geometry and you're adding intelligence into each of those sketches. You're putting constraints on the geometry, you're putting dimensions on that geometry, and that intelligence is built in by the user. And there are very similar workflows even in synchronous technology. But what you're going to notice is, as opposed to doing it on the 2D sketch, you're going to be doing it directly to the 3D model. In terms of changing or modifying a part, there's a couple of ways to do that. One was the first method I showed you, where you pick on a face and you select this tool here. This is what we call our steering wheel, and it allows you to essentially make what we call these delta changes. As I push or pull on a face, it's going to go ahead and make that change per the delta value. Whether I type that value in specifically or just click out in space, it's going to make that change just by pushing or pulling utilizing that steering wheel. The other way that I can make changes to a part is by adding dimensional information. So for example, if I were to add a dimension to the part here, it'll allow me to go and make changes to the dimension. And again, in this example, I'm utilizing a scroll wheel just to make incremental changes. Or if I type in a specific value for the dimension, it'll make that change in that regard as well. So again, two main ways to make those changes to parts is steering wheel and dimension. In terms of adding intelligence into the model, again, we saw how live rules will automatically add intelligence to the part, but then again, the user also has the ability to add in their own intelligence via what we call face relationships. And we're going to talk a little bit about these here in just a few minutes. But again, to correspond how you might work inside of a traditional modeling system, these are the tools that are very similar to that way of working in a CAD solution. So the example I want to go through is we're going to make several changes to this part, and again, we've got live rules turned off. And the first method I want to talk about is making a change via the select set. And what I mean by that is whatever the user selects on the model, that's what's going to be changed. So in this case, if I select that one face of this cutout, or if I come over here and select this other face, individually I can change this either by pushing or pulling with the steering wheel, or if I have a dimension tied to it, I can change that dimension. Now if I want to change multiple things, I just simply select those multiple things. So in this case, I can select both of those cutouts, and again, I can utilize the steering wheel tool and drive the change to both of those. Again, just reinforcing the fact that if I don't want to use the steering wheel, I can also utilize the dimension. So again, if I want to change those cutouts to be specific dimensions, I can go ahead and modify that and just type in the new dimension, and again modify both of those simultaneously. In a similar fashion, if I come over here and place a dimension locating these holes, again, if I have a dimension located to one hole, I can again modify that one hole via that dimension. Or very similarly, if I go through and actually select multiple elements, I can drive all of those holes simultaneously. What you'll notice here in the inside of our dimensioning toolbar is control over which direction the change is made. So you'll notice down here I've got the arrow pointed to the right, and those three holes that were selected are highlighted. So whichever direction I want the holes to move, I can either change the hole location and leave the edge of the part in its current location, or I may want to leave the holes where they are and just change the dimension by moving the edge. So again, I can change the arrow to the left, and I can move the edge of the part by modifying it in this regard. And if I come up here to the top of the part in a similar way, if I come up here and add a dimension to, let's say, the hole from the edge of the part, again, you'll notice that I can drive the location of the hole via a dimension. One thing I want to point out is you'll notice in the dimension toolbar we have these different arrows, and you'll notice the arrow currently is pointed to the right and the hole itself is highlighted. What that's signifying is that whatever is highlighted is what's going to be adjusted. So if I were to select, for example, the hole and move it in this direction, it'll leave the part edge where it is, but move the hole. Now I may want to leave the hole where it is, but move the part edge. So this is where I have the flexibility to change the directional arrow and move it to the opposite side. And then again, as we saw earlier, if I were to select multiple elements, I can change the part with the dimension via my select set. So in this example, I may come over and select all three holes in this case, and then again, as you'll notice that as I modify the dimension, I can move all three simultaneously. So again, everything is based off of what I physically select on the part. One other way that you can add elements to your select set as opposed to just individually picking items is to do a window selection. So maybe in this example, maybe I want to maintain the original design intent and keep the holes concentric with the outer rounds, and maybe I want to adjust the entire length of the part. So again, notice as I window select, I can now drag each of those elements either with the steering wheel and modify everything within the select box, or I could do the same thing by window selecting and modifying dimensions. So again, if I window select around everything here, you can go through and still make modifications by modifying the dimension. So this first method of the selection of elements is one way that you can manually control. The other thing I want to talk about is if you want to eliminate the process of having to select things, whether it's by picking or window selecting, is you can add in intelligence via face relationships. And this is very similar to what you might be doing today in a traditional system with putting constraints on the sketches. The difference, though, is I can add these face relationships between different features. I don't have to necessarily do it within a sketch. I can do it between different features. So again, what I want to show here is, and maybe in the example for these angled cutouts, I want to make sure that they always stay or be maintained as coplanar faces. So one of the relationships I have here is the coplanar relationship, and I just simply pick on the two elements that I want to be coplanar. What that's going to do is this: if I come over here to the edge bar, it'll capture that relationship that I just added to the part. And again, what you'll notice here is if I start to make modifications, whether it's via the steering wheel or this dimension, it'll actually modify both of those at the same time. I don't have to manually pick both of those to make that change anymore. Same thing over here. If I wanted to make changes to all three holes simultaneously without having to pick them every time, we have a tool here called horizontal vertical. Again, very similar to the traditional modeling constraint you might put on a sketch. So in this example, I want to tell Solid Edge to align those two holes, and we'll do the same thing where we align these two holes. And again, if you look here, we have those relationships are now captured. So again, I don't have to physically pick those if I want to make a change. I now simply just grab my dimension, and I can modify both of those, or I should say all three of those at the same time. Other things you can do with dimensions, let's go ahead and place another dimension on the part. Maybe we'll place a locating dimension from the edge of the cutout to the hole. You'll also notice this other icon, which is what we call a lock and an unlock symbol. So in addition to being able to control the direction of the change, you can also specify if a dimension is critical or if it's something that you don't want to change. So what you can do is you can hit that little lock symbol and lock the dimension. What you'll see graphically is the dimension will change color, and what that'll do is if I decide to make any changes, again via the steering wheel or the dimension, you'll notice that it's going to maintain that 50 millimeters. So if I move the holes in this direction, it's got to update the cutout at the same time because it needs to maintain that 50 millimeter dimension. Now, in the example where I may have this other dimension locked, so you'll notice I can go back into a dimension and lock it as well. You'll notice that I want to maintain not only the 50 between the cutout and the hole, but I also want to make sure that it stays 25 from the edge of the part. Then what you'll notice is I can change the dimension down here, and I can actually drive the entire model. And what you're seeing here, this looks very much what live rules will do for you automatically. So in this example, we've had to put intelligence into the part. We've had to add different constraints or relationships. We've had to put dimensions in and lock dimensions. And there's been a little bit of input from the user to make this work as we might expect. So we make a change to the part, and several things are going to update simultaneously. But again, it required the user to put in a little bit of extra effort that really wasn't required. This is something that Live Rules will do for us automatically. To summarize, what I want to do is talk a little bit more about live rules and introduce you to them more on an individual basis than on a global basis. And what I'm going to do that first is delete the intelligence that we added in manually with our face relationships. So let's go ahead and get rid of the horizontal and vertical relationships as well as the coplanar. I also can get rid of this dimension to the back. Let's get rid of that 25 millimeter dimension. I do want to go ahead and leave this dimension in because we're going to be making our changes via this dimension here, or we may make some other changes via the steering wheel. But again, I don't need as much input from the user to make changes when I'm utilizing live rules. So I want to go ahead and turn on live rules, but this time let's look at them more on an individual basis. So let's turn off some of the ones that are on by default, and let's just turn on, let's maybe start off with introducing concentric faces. And what maintain concentric faces will allow us to do is, as I make this change to this dimension, again, if I modify that dimension and modify the cutout, because I have this dimension at 50, notice how it's moving the hole to maintain that dimension, and simultaneously it's moving the outer edge of the part, and not doing that because we have a dimension tied to it, but it's recognizing that this hole here is concentric with this outside edge, and by changing this dimension down here and by having this lock dimension in, it's automatically going to change the size of the part. Had I not had the concentric live rule turned on, I would have to have that other dimension inside of the model in order to make this change. So again, maintaining concentric faces is going to allow us to, again, have less input and do multiple things. The other live rule we may want to talk about would be coplanar. Coplanar in this case, if I have it turned off, as I'm making the change to the part, notice how this cutout is not adjusting. It's only moving or adjusting the cutout that we have the dimension tied to. But if I go back in this case and add in coplanar faces, now what it'll do is it'll pick up any of the faces that are coplanar. So you'll notice it's also going to modify that cutout on the other side. Symmetric in this case would have done the same thing. So if I turn on the symmetric relationship, it would essentially behave, for this particular example, the same way. Let's go ahead and turn on this live rule called Maintain Coplanar Axes. With that live rule turned off, you'll notice that with symmetry it'll modify this hole, but it's not adjusting the hole in the middle. So what coplanar axes will allow us to do is automatically pick up those holes that are in line with each other, and as I make changes to the part, it'll go through and allow us to make all of those changes at the same time. So just to reiterate, live rules will apply all of the intelligence automatically for us that we had to manually input with face relationships and additional dimensions. So again, you can see how it provides a lot of benefit in saving you some time and some effort. I want to switch gears a little bit and just talk a little bit more about the steering wheel. We won't go into a ton of depth or detail, but I do want to introduce you to a couple of other things you can do with the steering wheel tool. One, we talked about how, as we drag a face, how we can automatically just push or pull on a face. But also, this steering wheel gives you the ability to also rotate faces. And again, you'll notice that I can rotate different options here. Let's go ahead and grab the angled face in this example, and if I wanted to rotate those faces, I could do that just by grabbing the steering wheel itself. But also just talking about how the steering wheel will also allow you you can modify its location. Notice how I grab it right here at the origin, and as I snap to different edges or snap to different faces, the steering wheel will automatically adjust itself to line up with whatever face or edge that I'm touching at that point in time. Now you can also readjust different elements of the steering wheel. As an example, if I'm touching this top face and I want to lie the steering wheel flat on that face, I can simply hold my shift key down on the keyboard and shift click on that plane, and it'll notice how it rotates it around in 90-degree increments. Other things you can do is you can drag these bearings, which are found at the edges of the axes themselves, and I can reorient them and point them to specific locations if I'd like. If I don't want the steering wheel to change position, I can hold the Shift key down as I grab the origin, and notice how it'll maintain its current position. So again, the help menu is going to provide a lot of detail on many different things you can do with the steering wheel tool. Again, its primary function is to modify the part by pushing it or pulling it, or by rotating the geometry. We're going to have some additional demonstrations that are going to show us utilizing the steering wheel in other applications, but for now we want to go ahead and wrap this demo up, and hopefully you earned and learned more about the live rules and steering wheel tool.